Question 17. A circle with centre at -2, 6 passes through the point 10, 11. Show that the circle C also passes through the point 10, 1. Well, the way we'll tackle this question is we'll find the radius of the circle and then show that the point 10, 1 is that same distance away from the centre as the radius, and therefore it must be on the circle. So we begin by finding the radius of the circle. And the radius is the distance between the points -2, 6 and 10 and 11. And it's given by the square root of the difference in the x-coordinate squared, that's 10 minus 2 squared, plus the difference between the y-coordinate squared, 11 minus 6 squared. And that gives us the square root of 10 minus 2 is 12, square root is 144, plus 11 minus 6 is 5, square root is 25, so that's the square root of 169, which is 13. So this circle has radius 13. So now we're going to show that the point 10, 1 is also 13 units from the centre. So distance of 10, 1 from centre -2, 6. And again, that's given by the square root of the difference in the x-coordinate squared plus the difference in the y-coordinate squared. So in this case, it's 10 minus 2 squared plus 1 minus 6 squared. And as before, 10 minus 2 is 12, square root is 144. 1 minus 6 is -5, square root is plus 25. And that's the square root of 169, which is 13. So 10, 1 is 13 units from centre and so on the circle. The tangent to the circle C at the point 10, 11 meets the y-axis at the point P, and the tangent to the circle C at the point 10, 1 meets the y-axis at the point Q. Show that the distance PQ is 58, explaining your method clearly. Well, here I have a diagram of the circle and the two tangents going through 10, 11 and 10, 1 and cutting the y-axis at P and Q respectively. And the way I'm going to tackle this question is to find the equations of the two tangents and then find out where they intersect the y-axis. So first of all, the tangent that passes through 10, 11. First, I need to find the gradient of the radius from -2, 6 to 10, 11, and that will enable me to calculate the gradient of the tangent. So let's say the radius gradient is the difference in the y-coordinates divided by the difference in the x-coordinates. So it's 11 minus 6 divided by 10 minus 2, which is 5/12. Now, if the radius has gradient 5/12, the tangent gradient will be -12/5 because the tangent and the radius are perpendicular. Now I can use y minus y1 equals mx minus x1 to find the equation of the tangent. Y minus 11 is equal to -12/5 x minus 10. So y minus 11 is equal to -12/5x. And when I multiply the -12/5 by the -10, it becomes positive. The 5 cancels into the 10 twice, and I get 12 times 2 is 24. So y is equal to -12/5 x. Take the -11 the other side, becomes positive. So 24 plus 11 is 35. And that cuts the y-axis at 0, 35. Same again for the other tangent, so I want the gradient of the radius from minus 2,6 to 10,1. Difference in the y coordinates, 1 minus 6, divided by the difference in the x coordinates, 10 minus minus 2, and that's minus 5/12. So that means that the tangent gradient will be plus 12 over 5. So I can use y minus y1 equals mx minus x1 again. And this time it's y minus 1 is equal to 12 over 5 x minus 10. So y minus 1 is equal to 12 over 5x. And 12 over 5 times minus 10 is going to be negative. The 5 cancels into 10 twice, and I get minus 24. So y is equal to 12 over 5x. Now minus 24, when the minus 1 comes across, it becomes plus 1. Minus 24 plus 1 is minus 23. And that cuts the y-axis at 0, minus 23. So we can see PQ, because it's a vertical measurement, we're just looking at the y coordinates, PQ is the distance between those 2 points, which is 35 minus minus 23, which is 58 units. And that is what we had to show.